Hello and welcome back to another video. This problem we're dealing with the function f of x is equal to x squared minus 1 over x squared plus 1. And we're looking to find the derivative and the second derivative. So for the first derivative, we're going to use the quotient rule since we have a fraction. That derivative is going to be equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. This is all over the denominator squared. Now, simplifying, we get x squared plus 1 times the derivative of x squared. We have a power function, so bring down the 2 to your coefficient. New exponent is 2 minus 1, which is just 1. X to the 1 is just x. Minus the derivative of 1 is 0. So minus 0 we don't even have to write. Then minus x squared minus 1 times the derivative of x squared we just found is 2x, plus the derivative of 1 is 0. So again, you don't even have to write that. Doing this over x squared plus 1 squared. Distributing, we get, it'll make it easier to distribute the denominator if we actually write both of the x squared plus 1's out. Distributing the numerator, we get 2x squared times x is x cubed plus 2x minus x squared times 2x minus 2x cubed minus times minus 1 is plus 1 times 2x is plus 2x over x to the 4th plus x squared plus x squared again plus 1. And this is going to be 2x squared, or 2x cubed minus 2x cubed is just 0. So we get 2x plus 2x is 4x over x to the 4th plus x squared is 2x squared plus 1. So that's the first derivative. Finding the second derivative is just taking the derivative of the derivative. And again, we're going to be able to use the quotient rule. So we have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. Now we're going to leave the denominator alone because it's not actually going to help us to simplify it. We are going to simplify the numerator, obviously. We're going to have x to the 4th plus 2x squared plus 1 times the derivative of 4x. This is a linear term, so its derivative is its coefficient, which is just 4, minus 4x times the derivative of x to the 4th. We have a power function, so you bring down the exponent. Subtract 1 for your new exponent, so 4 minus 1 is 3, plus 2, the derivative of x squared we've already found a couple times is 2x. So 2x squared is 2 times 2x, and then the derivative of 1 is a constant, so its derivative is 0. And again, I'm not writing the plus zeros or the minus zeros because it's not really useful. And here, distributing on top, we have 4x to the 4th plus 8x squared plus 4 minus 4 times 4 is minus 16, x times x cubed is x to the 4th, minus 4 times 4 is minus 16, or minus 4 times 2, however you want to think about it, and x times x is x squared over x to the 4th plus 2x squared plus 1 squared. We are almost there. Last step is to combine like terms in the numerator, so we have 4x to the 4th minus 16x to the 4th is negative 12x to the 4th, plus 8x squared minus 16x squared is minus 8x squared, plus 4 over the same denominator, x to the 4th plus 2x squared plus 1 squared. Again, you can distribute that if you want, but it's not going to simplify anything out with the numerator. So we're just going to leave it like that, and that is your second derivative. Now, part B is asking us to compare the graphs of f, its derivative, and its second derivative. And it's a little bit unclear to see what's going on here. But if you notice, when f, which is this curve right here, goes from decreasing to increasing, its derivative is 0. When its derivative, right here, goes from decreasing to increasing, its second derivative is 0. And when it goes from increasing back down to decreasing, its second derivative is 0 again. It's a little bit off in this curve, but in this hand-drawn graph, but that is how you can tell that you are actually dealing with the proper derivative and second derivative. You don't really have to worry about increasing and decreasing, correlating with positive and negative values when it's something as complicated as this. If you had a more simpler function, like I have this right here from an earlier problem, this would be more clear to say, okay, we have f is increasing, so the value of its derivative is positive. But for something like this, just worry about the zeros and you'll be good to go. But anyway, this is your derivative. This is your second derivative. As always, thank you for liking and subscribing. I'll see you in the next video.